Hello everyone, welcome back to another video on the topic of knowledge graphs, where we are going to use large language models to enhance our knowledge graph building and also querying process. On the screen, you see the result of building a knowledge graph using the videos that I have created under my YouTube channel. And as you can see, a couple of nodes, the one in the middle says title 277, object segmentation in Python. Sorry, 3D object segmentation in Python. And on the left, you see object segmentation and analysis. So there are certain nodes that seem to have a lot more connections than other nodes. And in this case, the reason is probably because it has to do with 3D segmentation, and there are probably other topics that I have covered where this happens to be related to. And how do we get this information? Like it says difficulty is intermediate and duration is about 10 minutes, and topics are 3D segmentation, Voronoi labeling, and the library that I ended up using. Well, in the last couple of videos, we did cover something similar in terms of how to assign this metadata from the data that we have and how to connect these videos and all that, how to connect these nodes. And by the way, this is not just working on the video itself, right? So that's another level. If you want to just use a large language model to analyze an entire video and extract the keywords, that would be amazing. That would take even more resources, but that would get much more rich data. In this case, I have exported my list of videos, the titles, the duration, of course, and also the description I put in as part of these videos. So the knowledge graphs are completely built using that information. And large language models, they have the ability to extend or the semantic meaning of some of the words that we have in this data set. Okay, enough of introduction. Just a quick overview of what we have done actually. Like we are using LLM right now, but we have actually covered knowledge graphs for the last few videos. And again, this would be a great time for you to pause the video and hit the subscribe button if you're not already a subscriber. Okay, but jumping in, looking back at video number 356, that's 2 videos ago, we did a fully manual where it's an expert-driven method, right? So it's a fully manual, which means you're defining the nodes and metadata, everything manually. You're saying, hey, this is my first video, and this is about Python basics, and it covers whatever the topics, and you define that manually. We defined that manually. And then we said, okay, we have like a few videos on the topic of financial analysis, a few videos on the topic of bioimage analysis, and we defined the metadata and all that accordingly. Now, I keep saying videos, this can apply to anything. Anytime you're actually defining a knowledge graph, if you can actually do everything manually, that is great. But if you have like 400 videos like I do with a lot of nuance, like some videos cover like the basics, but also they relate to financial analysis. Like if there is a lot of let's say different type of metadata associated with it, then manual is probably not scalable. I mean, then you have to be very careful at entering all these details, but still preferable if you can, which is possible if you have like tens or maybe hundreds of content, pieces of content. But if you have like thousands and 10,000s and millions, like YouTube and Facebook, they have so many images, then it becomes a bit impossible to create these manually. We manually defined everything, and I don't want to make this a boring PowerPoint presentation, but the key advantages of fully manual is you have full control, right? Expert curated learning paths, you can create those, and you have full control over how the knowledge graph should look like. But the key limitation is it's of course labor intensive and it doesn't scale with large content, which is why in the next video after that, in video 357, we covered natural language processing enhanced approach, which is actually automates this process a little bit, right? So it uses NLP, in our case we use spaCy, to automatically extract key concepts from this video content. And then we chose to create a knowledge graph where each video becomes a node. In fact, it can be topics, it can be series, let's say, let me not go through a rabbit hole of what it could be, but yeah, individual videos, nodes. And we use spaCy to identify these key concepts, like in the titles and also in descriptions. And we use sentence transformer to generate the embeddings, right? I mean, we extracted these nouns, or you can call them key concepts, or type from these titles and descriptions. But at the end of the day, we converted that all into embeddings, vector embeddings, and we calculated the similarity between them using cosine similarity. It can be phi, or it can be any other method that helps you get similarity between two vectors, or vector embeddings in this case. Okay, so that was the approach, and of course, it automatically creates the edges based on the similarity. We say, okay, calculate all the similarity between these nouns that you extracted from videos, and then find similarity. And similarity basically, below certain threshold, or let's say if two videos are more close, then hey, let's go ahead and connect them, and that kind of defines the relationship. And that's how we kind of automated that. Of course, the advantage is it scales much better with larger content, and automatically discovers the relationships, which is why it scales easier. And the spaCy, when it comes to limitations, spaCy is great, but it's great at identifying nouns, but doesn't understand the deeper meaning, right? So for example, if I have a topic on transcriptomics, unless I tell that, hey, someone who's interested in bioimage analysis or bioinformatics is interested in transcriptomics, it doesn't know. I have to manually include that at some point, that type of keyword. This is the advantage of large language models. For them, I can basically say, hey, find all the related terminology for a specific video keyword, right? So if it's spatial transcriptomics, it's like, okay, maybe bioimage analysis and bioinformatics are relatable. And if you say aerial photography, maybe it can say when someone asks a question about, show me all videos about remote sensing. So it probably includes these aerial. I say probably because large language models, it depends on the model itself. I'll get to that. Okay, so this is what we have done in the last video. And in this specific video, we're going to replace that spaCy part with large language model. So it uses the language model and semantic embedding. So we have to use the semantic embeddings, at least in this case, I ended up using them to create this hybrid approach for knowledge graph construction. Why LLM? Because they understand the context, like I already mentioned. I was mentioning bioinformatics, for example, bioimage analysis or microscopy. So whenever you ask a question, a query, this knowledge graph about show me the learning path for spatial transcriptomics or bioimage analysis, these topics should be related. And LLMs, the assumption is they understand those topics better than just hard coding, better than just the spaCy approach that we used earlier. Now, in our approach, we use a template-based approach to ensure consistent metadata extraction. I'll talk about what that means, because I tell a large language model, hey, extract all this information, but then how do you supply it to the next level? You need to kind of format it into some way. And the way I did was basically asking the large language model to format the data in a specific JSON structure. Okay. And of course, LLMs inverse meaningful relationship between concepts beyond simple similarity. Of course, similarity is one of the aspects that we're going to use, but large language models also can actually identify this to some extent, right? So is this an advanced or is this not an advanced? Also getting this accurate difficulty level, right? So is this a beginner? LLM can infer that information. I'm not saying LLM is better than a human, but if you have thousands and thousands and thousands of data, then LLMs can definitely automate this process. And which LLM, again, this is something you have to investigate. Definitely the smaller models in my experiments here did not perform well compared to larger models. For example, when I say ask the smaller model to extract this information and then put that into a JSON format, it completely ignores my command about putting that into a specific JSON format structure. It just extracts something. And then I went to this Mistral, the 4GB model. It actually worked pretty amazingly well. I bet if you have access to a good hardware and a good larger model, then the results are going to be even better compared to what I'm showing you here. I'm just showing you stuff in, I am going to show you stuff in Google Colab so you can reproduce what I'm trying to do here. So, but feel free to enhance it using better models. Okay, and let's move on. Of course, we are using embeddings to find semantically similar content even without exact keyword matches, because we are getting extra keywords, related keywords using large language model. So the key components, I should say, there are many, that's a long piece of code. So I'm not going to go through code line by line. I'll do that block by block in terms of what the purpose of that block is. And I'll share all the code, and the link to the code is down below under description. But the key noteworthy components is something I want to address before we jump into the code. One is large language model based entity extraction. I'll show you what that means in a second. And then the relationship extraction. Entity is basically, let's say, in other words, let's say nodes and relevant metadata. And then the relationship extraction is like the edge, like which nodes need to be connected. And complex query understanding. Basically, when you say, show me all the videos related to whatever, blah, 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 the LLM has a better chance of interpreting it, even if you kind of ask the question in different ways. Without LLM, that can be a bit challenging. Then you need to stick to certain format or template. And concept-based learning path generation, I'll show a few examples, starting with the LLM-powered entity extraction. So here I have a function where I kind of import the large language model, and I give a prompt like this. Hey, you are an AI trained to extract information from educational videos. Follow for this video, for the following video, and that video comes with what? The title, the description, the time. So all that information that's coming from the CSV file that I have. I'll show you the CSV file in a minute. Complete this JSON template by filling the information between the brackets, right? So, and then I give a template where it needs to fill the main topics, the difficulty, and the prerequisites, learning outcomes. So all of these, based on this video, I'm relying on large language model to kind of fill that specific template. This is where I'm using LLM to extract entity, and of course in the next couple of examples, like for example relationship extraction also, I'm going to provide a prompt saying, hey, again, you are an expert in educational content organization. It's very important to give LLMs a persona, so they kind of assume that persona and then give the answer, hopefully a better answer compared to just saying, hey, give me this, right? So just I don't want to, people call that prompt engineering, but it's very basic. It's just give it a persona, ask it a question. The next part, I've extracted the following topics from a series of educational videos, right? That's the previous step where it extracted all kinds of topics. And then please identify meaningful relationship between these topics. And again, this is the second, the relationship extraction, and then the complex query. Let's say we build, once you have the relationships and once you have the nodes, you can create a graph, right? So a directed graph. And the next step, once the graph is there, is querying it. And for querying, you should, I mean, there are built-in functions provided by like one of these Python libraries that you use for knowledge graphs. But if you can use large language model, like for example, we are saying you're an AI assistant helping users find educational videos, analyze this query, and then extract the following information. Then whatever you query, it extracts this information. What is the search type? What kind of search is this? Is this like exploring different topics, or is this is the user asking for a learning path, or finding prerequisites? You can say, hey, I'm interested in 3D segmentation. What videos should I watch to learn more about 3D segmentation, right? So it looks at all these prerequisite videos and then lands you hopefully at the right 3D segmentation video. And so that's the query understanding and learning path generation. For example, once it understands that the query is about learning path, then we have to translate that into some, into a way that we can extract the learning path. And for that, again, this is another helper function like generate concepts based on learning path, which you'll find in the code. We are going to jump into it pretty soon. Okay, obviously the advantages of LLM powered is its deepest understanding. By the way, I gave like my context and everything to a large language model, and the same one that I am actually going to use in a few minutes. And I asked it to give me, hey, what are the advantages and limitations of these three approaches? And that's what I'm showing you on the screen. So I don't take credit for some of these advantages and limitations slides, but I was curious. I just wanted to use it. Why not use it? So deepest understanding of content relationships, obviously large language models, we established all of these, right? So generates personalized learning paths the way we built it. I think this is more, it's interesting. I should have actually looked at this at a deeper level. I asked it about, I gave it all the information and I said, hey, what are the advantages and disadvantages? Apparently, it's just giving me the advantages and disadvantages of not just LLM powered, but my code, my approach. So based on my approach, it can infer prerequisites, it generates personalized learning paths, handles complex natural language queries, and whatever, blah, blah, blah. Okay, you got the point. I'm sure you're bored of the presentation. Now, before moving on to the actual code, I read quite a bit about what's going on in this field in the last like couple of months or so, and I'm recording this at the end of April 2025, and in April 4th, like earlier this month, there was a paper on a lightweight reasoning framework for large language model and knowledge graph. I'm not saying this is the next breakthrough paper, I just found this. There are a few others, but this is one of the recent ones that is directly related to what my interest is through this video, right? In this video. So this paper, basically they're proposing a lightweight framework, and you can read all the text here. This is basically the summary I got, right? So it uses a 3-component retrieval, embed, and reasoning system, a framework, I should say. And the goal here is, apparently they say even small language models can perform complex reasoning over the knowledge graphs. Please remember earlier I mentioned I tried a small language model, I think it's a tiny llama, and it did not work well at all. And if we follow this framework, potentially I could be using small language models. I did not test that, but I'm summarizing what's in this paper, yeah? Okay, so I think that's enough, and the link for the paper is down here, and it's easy to Google search and find that. But it's time for us to look at some Python code and not make this video any longer than it already is. So let's jump into the code. Okay, before jumping into the code, let's have a quick look at the CSV file that we are using as input, and it contains information about all 450-ish videos from my YouTube channel. And the first column is showing you the approximate duration in milliseconds that we will convert to minutes as soon as we import the data into our code. And the last column shows you the published time, 2019. This is again another thing, we will have to convert that into some date time format when we import this data. And the two columns where bulk of the information is contained is this video description and the video title. So we're going to extract entities from these video titles, like for example, what is this video about? And metadata can be extracted from this video description, right? So initially I was not good at description, just a couple of sentences, in some cases not even that. But the later videos, like if I go all the way somewhere in the middle, you should see much more information. So I got better at actually providing description as we progressed, through these videos over the last 5-6 years or so. Okay, this is what's going into our code. And just to have a look at the code, okay, I'm going to use GPU, so kill that. Okay, so building an educational video knowledge graph, blah, blah, blah. I included all kinds of information down here, so please go through it. And I've already connected this to a runtime with GPU, free GPU. So you should be able to reproduce whatever I'm showing you here. And the link to this file and also to the CSV file should be down under description. Check the CUDA version just out of curiosity, and also mount your drive because you're going to download a 4 GB language model, and you want to store that at a more permanent location than a temporary location. So go ahead and connect it to Colab, your Colab to the Google Drive. And I installed Llama CPP Python. In fact, I included this line later on, so I may as well comment this line. But since we're here to explain, if you're working on your local workstation, go ahead and install full-fledged Llama on, and you can use a Llama model from there. But because I'm on Colab, I'm using this Llama CPP Python 0.2.38 works on, like, this is end of April 2025. This is the one that actually worked fine for me. The next thing I installed was sentence transformers for embeddings, and NetworkX for knowledge graphs, and PyVis for visualization. Okay, now here I commented all of these. The first one is a large model from Llama model, and you can download it, but we're downloading those from Hugging Face. So if you have Hugging Face account, go ahead and get the API key, because this first one requires that information. But this is the preferred way, the second one, where you can just download this Mistral, which is still not a smaller model. It's a 4 GB model. And I downloaded that and placed in my Google Drive, and we're going to import it from there. I've also experimented with Tiny Llama. It did not work well, so I don't think you should try that and waste your time. Okay, so these are all the libraries we're going to import, and I am creating just a directory called knowledge graph results, so all the results can be stored over there, and let's go ahead and run that. And I divided this code into different blocks. The first block being model setup and initialization, and the next block would be reading the data and so on. So it makes it easy for you to follow, and I also added some text up here to summarize what's going to happen in that specific block. Okay, obviously this block is about model setup and initialization. So set up LLM GPU. This is what I was mentioning earlier. I've already included that part here, right? So if there is any existing installation of Llama CPP Python, go ahead and uninstall it and go ahead and install it again with the same specific version. I included this here to make it more, streamlined than actually, installing it separately. Okay, so that is getting the LLM GPU set up, and then once it's set up, we need to initialize the LLM, right? It can be a single line if you want. Because in this case, I was experimenting with a few different, I'm like, okay, which one is it? But in our case, it's going to be Mistral, like this one, that we are going to use. Okay, so we just downloaded that, so we know exactly where it is. That line goes here, and we are going to initialize it right there. So my LLM is Llama, with model being the model I just mentioned about, and all the other parameters. Excuse me. Like larger context window, optimized batch size, more CPU threads, whatever, you can play with these. Let's go ahead and run this block, and these are just functions, so it should be pretty quick. We are going to call them later on at the end, obviously. Okay, and this part is done. Let's go ahead and move on to the next part, which is data loading, which is as straightforward as it can get. I'm using pandas to create a data frame, and when the data is imported, we're converting our milliseconds into minutes, and of course converting the timestamp to some sort of a date time format, and cleaning up and standardizing the text fields a little bit. So let's go ahead and run this part. The next comes extracting data. Now that we loaded the data, we need to extract the data, and there are a few functions here, but the one that's worth mentioning about is probably the last one, where we are creating these prompts. And the prompt is, you're an educational content analyzer specialized in extracting structured information. Analyze these videos, and the videos go in. I mean, I'm doing this in a batch way. You can do one video at a time. It doesn't matter. And analyze these videos, and then the videos go in here. And then the prompt is, for each video above, you must identify the main topics, difficulty level, prerequisites, learning outcomes, with further instructions. And I put important here. So it understands, the large language model understands how I need my output. your response must be a valid JSON array with the following extract structure. And I put like a structure. This way, it makes it easy for us to build, not even easy, it makes it possible for us to build our nodes, define our nodes, and then define our edges and so on. This is where the smaller models were failing. They kind of extract some information, but they've completely ignored this important, put it in JSON. And I was like, code was failing. I'm like, what's going on? Why is it giving me JSON errors? And then I realized, oh, the small model didn't do what I asked it to do. My mistake. So I think that's the key piece we should look at. And here is another one, extract video entities. And here there is another command to LLM prompt, I should say. You're an AI trained to extract information. I showed this in as part of my slide deck. So now you're seeing that in action here. So let's go ahead and run all of these here. And is there anything else that's worth talking about? I talked about other functions in the previous video, so I'm not wasting time. And we are extracting video entities. We just looked at this, and let's, I don't have a mouse because all my USB slots are taken with the microphone and camera. So I'm using my fingers. So I apologize for slow scrolling. Okay, so all of this, again, self-explanatory, I should say, and then the relationship extraction, which is basically for our edges, right? So to find out the relationship, again, we are using LLM by providing a prompt so it can help us extract this information. So again, so the prompt here is, you're an expert in educational content generation. I've extracted the following topics from series of educational videos, and the topics we are actually getting from the topic list from the earlier step. And then please identify meaningful relationship between these topics, right? So that's pretty much it. And we are mapping the relationship type in terms of, is it a prerequisite video, or what is the type, right? Is it building upon, or is it related to? So what type of video relationship exists? And that is the relationship. And the next part is actual construction of knowledge graph. And the knowledge graph constructions is basically we are adding nodes and edges. And the information is coming, the title, description, difficulty, duration, and all of these, they're actually coming from earlier steps, right? So where we kind of analyzed our CSV document, like description and titles, and came up with some of this information, like topics, for example. The title is title, the video title. The description is the full video description. Obviously, the difficulty is something it kind of infers, like is it difficulty lower or, intermediate, beginner, advanced. Duration is something we have, it's not no LLM, we know what it is, and we convert that duration into minutes. And all of these are attributes for that specific node. So we are including all information for that node. And for now, we are just looking at each video as a node, but nodes can also be different topics to make these graphs more complex. But for now, we should have 480, 450 plus, around 450. How many other videos I have? That many nodes. Okay, and add video connections. And this is where we are adding the connections between videos, as the name suggests. And we are calculating the similarity score right there, again, similar to the last video. And anything else here? Anything else? I think not much to talk about over there. And the embedding generation. So generate the video embeddings. Here we are going to use our the library, the sentence transformer library that we imported. So that's the next step, and we are going to save the embeddings into a different file just so we can kind of load them later on if we need it. Okay, so the next step is storing the graph. Like once you build the graph, we need to store the graph, and that's this part. Not much to discuss there. And I'm storing the graph as a pickle file directly that we can load later on, and also serializing the graph into a SQL database. And then you can load SQL database also, right? Different tables and create your graph again. But in this case, we are going to load the graph directly. Okay, so that's pretty much it. And of course, there are certain functions for visualization. No point in going through. This is basically visualize the entire knowledge graph, visualize the subgraphs, and visualize, yeah, based on the topic. Once the topic is generated, go ahead and visualize the subgraphs. And then now we are ready to construct the main graph. All the helper functions are defined. So how are we defining? So basically what goes in is the CSV path, our model type. I was experimenting with tiny. It's okay. We're going to change that later on, whether to use GPU or not and all that stuff. So let's go ahead and define the main function there. And the main function brings all aspects together. So not much to explain here. And we are calling our initialize LLM and load video data. So all the functions we just defined, we're just importing them one after the, calling them one after the other. Okay, so this information is also fine, and we are building the knowledge graph right there using our video data, video entities, and relationships, right? So this is how we are building our knowledge graph, and then saving the graph into a database, SQL database, and also saving the graph as a pickle file. And we are also saving the embeddings separately, and we are creating the visualizations right there. In this case, we are just doing visualize the knowledge graph, the entire knowledge graph. But once we start querying, we can actually save different aspects of it, which is what I am showing you down here. One goal could be, I want to learn Python for bioimage analysis, right? So then it's going to generate the learning path using our LLM and the graph as input. And we have generate learning path as a function earlier. Go ahead and look at it to see exactly what's going on. All it does is it takes the LLM, takes this information, and supplies it to your, applies that onto your graph. Let's move on to defining a few more functions. Like, okay, we pickled the file and we saved it as a database, and here are the functions to actually load the graph and load the graph from database, for example, and load the embeddings. We saved embeddings earlier, and load the knowledge graph system. So once you save it, go ahead and load the graph like embeddings and initialize the LLM for querying. So basically here it's just load the graph, but here we are actually loading the entire thing. So if you want to load it, use it offline. Like once you build the graph, right? And you want to do proceed, and this is exactly what's going on. Load the graph and the embeddings and initialize the LLM. So everything is ready for you to query. So I think that's enough. And the next step is, okay, so now the system is loaded. Now we can perform all these semantic searches, right? So it finds the video similar to whatever you are querying by comparing the embeddings. And this is why we created these embeddings and we saved them. Okay, so that's the function that we have for semantic search and expanded keywords. Basically what I'm saying down here is, hey, if the keyword is Python, the main one, then also extend that to programming, coding, and development. When someone says, how do I learn Python, then also interpret that as how do I learn programming, coding, or development. So some of the extended keywords, basically expanded keywords down there, expanded query concepts down here. Basically here I'm using a LLM to expand the query, right? So the query can be, hey, the query can be, do I have an example here? Maybe later on. So the query can be, show me videos on spatial transcriptomics or something. And this is where it kind of finds related topics, and then it expands the query to those different topics. Yeah, so that's pretty much it. And then the query processing using LLM for understanding and embeddings for semantic search. So basically, the prompt that I'm providing LLM is, hey, analyze this query, whatever the query the user actually provides. And what kind of search is this? We saw this in our earlier presentation. Is this topic exploration, learning path, whatever? Get all the information right there. Anything else I want to show here other than that? I don't see much of anything else that requires extra explanation. Let me go back. Okay, so node, it's actually looking at the nodes and looking at the embedding match score and adding the filter videos and sorting these videos by the matching score between them. And yeah, not much. And load and query, we are going to load our pickled graph and we are going to run a query on it. That's another function that I literally added at the end. And learning path generation. So you can add more functions. I mean, these are some of the things we can do with the knowledge graph, right? So these are just some of the stuff. I mean, learning path. So generate a learning path for a specified goal. And again, I want to use LLM. So there are many examples. These are just a few I'm showing you. So you're an educational content curator, create a learning path for whatever the goal is. I want to be a bioimage analysis expert, right? So you type that in and then available topics, it's going to go ahead and look for those and include only relevant topics as part of the JSON file, and then it returns the JSON file to us, with all the information. And again, basics and videos for learning path. And we created the learning path and what videos for each topic in the learning path. Again, once you have the learning path, which videos belong to a specific path. The learning path can be topics. It's basically a topic-based path, right? I want to be image analysis. So Python basics, which videos belong to Python basics? Next comes image understanding images. What topics come under understanding images? What videos do I have that fall into that? So this is basically that specific step, okay? And then formatting it and generate the learning path. It uses the previous functions, brings everything together, and visualizing the learning path, okay? So I told you this is a lot of code, and going through each line doesn't make sense. And you can actually take a block and then reverse engineer it and feed it to LLM and then ask what exactly is going on here. Although it's very straightforward. Okay, so a couple more functions and we are ready to actually run them and see some results, right? Generate a concept-based learning path using semantic similarity. And again, it's not just a topic-based, but also the concept-based. So here I'm saying you're an educational content, blah, blah, blah. Identify the key concepts needed to achieve a specific goal. You're saying, hey, I want to be this, a data scientist, specializing in financial analysis. Show me all the videos corresponding to, that achieves my goal. So that's one example right there. So, and visualize the concept. So for every one of these, I have a visualization, so you can kind of look at the PyViz graph result. And now let's go ahead and run it. So first, to build the knowledge graph, right? We are running the main function where we are providing the information about, the input and what model are we going to use, and are we generating the embeddings? Of course we are. And I gave like a max videos of 10 just so it's faster for this demonstration purposes. But I have a video I have a knowledge graph that I saved for all 450 videos that will load in a second. But just so that you can see, it's actually GPU detected. So you see how the screen output looks like when it's actually using this large language model. Okay, so it started printing something. So processing videos, you see it's using large language model at multiple locations, so it's not really super fast, even with GPU. I hope it's using GPU, right? So there you go. That's where the GPU started. So yeah. You kind of need GPU, otherwise this will be extremely slow. Okay, so I think this is it almost done? Yeah. So one of the last things it's going to do here is example LLM output. Like for each of these videos, it's extracting information. So in the function, I put like, hey, print out the JSON for the first one. So we know what's going on here. So the first video was, why do you need to learn programming? And the description is right there. LLM response is right here. So the main topics here. So now you can see what the essence of all the functions are, right? So what is each of those actually? I wish I could go each function by function and print out the output, but this is one way of bringing it together so you understand what's going on. So the main topic it extracted from that video is the importance of learning programming, career advancement through programming, benefits of learning programming for students and researchers. This is what you saw the document. All of this is not part of, at least I don't think so. Let's go ahead and look at, yeah, it extracted all that information from here. If you are a student or researcher in any field, you eventually run into need to learn the code, programming will make blah, 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 whatever the text. It kind of summarized that into importance of programming, career advancement, learning programming, students and researchers. And the difficulty, of course, is beginner. There is no prerequisites, so the list here is empty. Otherwise, you would see a list of videos that are prerequisites to this specific video. And the learning outcome here is understanding why learning programming is essential, recognizing the benefits of programming, and so on. I hope this kind of gives you an idea of why we had like all those functions we defined earlier. Okay, so it did all the 10 videos, and let's go ahead and look at some of the key features. First thing first, semantic search with embeddings. So first, let's say videos related to unit is my, there's a function earlier that we defined called handle user query that takes in our LLM and the graph that we just created and the embedding models and videos related to unit, right? So it's going to look for the semantic results. And again, look at the function and see what exactly it's doing. But here is the output. We are using LLM as part of this, so it is going to take a few seconds. It's not an instantaneous result is what I mean to say. So what are the videos related? I hope it finds decent results related to unit. It's got 0 matching results. Oh, I know why. Because we only did 10 videos. In the first 10 videos, I don't have any unit related videos. We're going to load the model in a second and then run similar query again so we can see exactly what the results are. This makes absolute sense. Okay. The next one is we are using handle user query again. And here I'm asking, show me advanced deep learning techniques for image segmentation. Again, I haven't covered that in this video yet. I mean, in the top 10 videos. So let's skip that. And filtering content by difficulty level. This should all show probably the basic ones here. Beginner videos, right? I mean, that's what I'm querying. Show me beginner videos on Python. So it's actually showing you those videos right here. And concept-based, again, master computer vision for medical image analysis is the concept. And for that, we have a function called generate concept-based learning path. All of these are different variations of the prompts that we actually provided. So the large language model can be applied onto our graph, right? So that's basically it. And let me skip that because that's not part of the top 10 videos, the first 10 videos, not top 10. Now let's go ahead and load a pre-built knowledge graph system. We stored that, I stored that earlier, and I called it full knowledge graph, full video embeddings. Let's go ahead and use the load knowledge graph system. Remember, it loads the embeddings and the knowledge graph, everything, and gets the knowledge graph ready for us to kind of query it. So let's go ahead and load that and then start querying, and I'll stop this video. I bet it's longer than 40 minutes or so that I kind of defined or set for this video, but I appreciate your patience if you're still watching it. Okay, so it did load it, and now we are ready to start. But first thing is, let's look at basic statistics about the graph, right? How many total nodes are there? How many total edges are there? How many beginner, intermediate, advanced, and unknown videos, and so on. So let's go ahead and print all of that so you get a good understanding of what's going on. So I have 438 videos and 3,842 edges. So that many are connected between these 438 videos. And I have 831 unique topics, and topics are the ones it extracted from these videos. And a specific video may have multiple topics, by the way, right? So it extracted 831, and I have most of the videos it did categorized as intermediate and 2 advanced and 3 unknown. Maybe I should improve my prompt LLM prompt. So to get, because I do have a lot of advanced videos, and maybe it thinks that they are not advanced because it analyzed the text and I did not use the terms advanced or complex or some of these keywords or extended keywords. So it thought that, okay, it's probably not advanced. Okay, so that's that, and let's look at sample queries from the original code. And again, I dumped everything here. Videos related to unit. Show me advanced deep learning techniques. All the previous queries I kind of included again, so we can have one final look before we stop this video. Okay, so first one, show me all videos related to unit. I'm glad it's showing you. I don't know why I don't know if it's showing them in certain order. Based on the similarity, right? So it's going in decreasing similarity. So it looked at unit. It's like pre-training unit using autoencoders, and then image segmentation using unit, part 1, part 5, part 6. So these are all, if I expand this to from top 5 to top 10, it probably will get all the my unit video series right here. The next query was show me advanced deep learning techniques for image segmentation. So it's used image segmentation using unit, traditional machine learning, and blah, 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 whatever. Show me beginner videos on Python. We already saw that earlier. And concept-based learning. Let's go ahead and do that. Master computer vision for scientific image analysis. Okay. And so let's see what it actually generates. And again, we need LLM. That's a good sign. Prefix match hit means it's doing something there. And let's look at the result. Okay, so there are 9 concepts and 45 videos. So this one says image processing using SciPy in Python. So let's take a step back. When I say concept-based, when I say mastering computer vision for scientific image analysis, it's actually looking at all the videos and it's saying, okay, so this is the path. First, do image processing, and then understand what the pixels mean, and then what do image filters mean, and then what does edge detection mean, what does image segmentation mean, and each of these topics there are multiple videos, right? So it's going to put, and I believe I have a visualization for that because all of these are stored, visualization saved to whatever concept master. Let's actually download a couple of these and then have a quick look and then stop this video. So here is the full knowledge graph, and as you can see, I mean, we can zoom in if we want, and we can have a quick look at what these are, and you can obviously move these around and investigate it further. Again, it's let's turn the physics off because this is way too many nodes, and it's trying to move, it's trying to make it elastic and all that, but we don't want that for now. Okay, so this is object segmentation using Voronoi. This is what name change. Anyway, I'll let you play with this, but more importantly, let's go ahead and look at these. This is learning path for bioimage analysis. As you can see, these are Python basics, and then reading images from Python. And it's what is this called? This is data analysis. Okay, these are all the videos about data analysis. Again, I'll let you explore it on your own. And this is the master computer vision for medical image analysis. So it divided this into various concepts right there: image processing, pixel, image segmentation, feature extraction, machine learning, deep learning. For each of these are the videos you need to watch. So this is the learning path that it actually created. So I hope you found this to be interesting. If you're still watching this, probably you appreciate the importance of large language models and knowledge graphs. And again, feel free to download the code, which is down under description. And of course, I request you, as usual, to hit the subscribe button. Thank you.